3.2. Okay, let's look at the first question. The graph y of y is equivalent to p of x are given in the figures. Okay, some of the polynomials p of x in each case. Okay, for some of them, right, you need to say the number of zeros of the p of x, right? As it is saying that it is p of x, you need to look at only at the x-axis. Okay, if he has given here something like this, x is equal to p of y, then you will be looking at y-axis. Hope it's clear to you, right? So let's look at the first sum over here. Looking at the first one over here, right? It is not touching the x-axis, right? So for this, the answer would be no zeros at all. There are no zeros for your p of x. So if you're looking at the second one over here, if you look at the x-axis, it is touching at only 1 point, right? So the number of zeros for p of x are how many? 1. These are your number of zeros. If you are looking at this, the next bit, the number of points where the x-axis meets is 1, 2, and 3. Here, p of x has 3 zeros, right? Good. Now, if you're looking at the next one over here, the fourth one, if you look at this, it is intersecting at 2 points. P of x has 2 zeros. Is the answer here 1, 2, 3, and 4, right? So for this, the number of zeros for p of x are how many? 4 zeros, right? If you're looking at the next one here, 1, 2, 3, right? The number of zeros for p of x are 3 zeros. Hope it's clear. So let's look at the next one a bit. Okay, in this bit, he's asking us to find the number of zeros of the polynomials. Okay, let us see this, how we can do this. So here he has given you this. What I'll do is I'll just suppose let p of x is equivalent to 0. So I'm substituting that one over there, so that 3 of x is equal to 0. I'm shifting the 3 to the RHS. So I'll get 0 by 3, which is equivalent to 0 itself. Okay, so the number of zeros, therefore, the number of zeros, so I can say that clearly over here, the number of zeros of p of x is equals to 0, right? So if you look at the next one over here, I'm having this one. So let p of x, so let p of x is equal to 0. Then I can write x square plus 5x plus 6 is equivalent to 0. Now you're removing the roots of this equation, so that I can write this x plus 3x plus 2x plus 3 into 2 is equals to 0. I'm taking out the common terms. So x is equals to x plus 3 plus 2 into x plus 3 is equal to 0, right? So the root what we obtained is x plus 2 is equals to 0 and x plus 3 is equal to 0. Subtracting the numbers to the RHS side, x is equal to minus 3 and x is equal to minus 2 are the roots of the 0, are the zeros of polynomial p of x, right? So what are the, see, you need to understand that the roots of p of x is the zeros of p of x. Hope it's also clear to everyone, right? So let's look at the third bit over here. So here also the third bit, I'm just assuming that p of x is equals to 0. Let p of x is equals to 0, right? So what I'll get is 0 is equals to, I'm doing this 2 into x plus 3 plus 2 into x plus 3, isn't it? Now I'm doing this one into, I'll get x square plus 3 times of x. Okay, x plus 2 can be written over here, and eventually this is your x plus 3. Hope you get this, right? So this is the reverse of this one. Means I can do this one directly. These are the roots of the equation. No need to solve this one. Hope it's clear, right? So if you're looking at this one, equating this one to 0, what I'll get, I'm writing it up over here. X plus 2 is equals to 0. X is equals to what? Minus 2. And similarly, x plus 3 equals to 0. X is equals to what? Minus 3. So the solution for the third bit is p of x has x is equals to minus 2 and x is equals to minus 3 as zeros of the polynomial, that is your p of x. Okay, good. So let's look at the fourth one over here. if you're observing the fourth one over here, I can write this as x squared to the whole square minus 4 to the whole square is equivalent to 0. As I'm supposing that, let a of x is equal to 0, right? So what would be the resultant if you are observing this? This is nothing but your a square minus b square, right? So the formula to do that one over here is quite simple. You need to see that this I can rewrite this as x squared minus 4 x squared plus 4 is equal to 0, right? Now I can also rewrite the equations, that is the roots of this equation should be x plus 2 and x minus 2. I can write one of the equation to be like that, right? So similarly, or x plus 4 is equivalent to 0, right? So when I'm equating everything to 0, I have the roots as x is equal to 4 minus 2, or x is equal to what, 2, or x is equal to what, plus or minus 2. Alright, so these will be the required equations. So these are the zeros of the polynomial a of x is equals to x is equal to 4 minus 16. Hope it's clear to everyone, right? Okay, if you read the next question here, he is asking us to draw the graph of the polynomial and find the zeros, justify the answers he says here, right? Okay, first of all, what is the justification required? The justification is the root of the equation, isn't it? So I'm taking out this equation over here. Okay, so how can I get the roots of this equation? I can get this as x squared can be written as x into x minus x needs to be written as minus 4x plus 3x, and a minus 4 into 3 is equal to 0. Now removing the single terms outside, that is x is removed out, x minus 4 is left, plus in this one over here if you're looking at this, 3 is removed out, right? So 3 into x minus 4 is equal to 0. So the roots of this equation is x plus 3 is equal to 0, or I can say that x minus 4 is equal to 0. Now I'm shifting M to the RHS over here, right? So the result of this one is x is equal to minus 3, and the resultant of this one is x is equal to 4. Hope this is clear to I'm substituting the values of x over here as I'm having the values of this one here. The first value can be written as minus 3, right? Comma, the next value can be written as minus 1, the next value can be written as 0, the next value can be written as 1, the next value can be written as 3. Hence, I'm taking the values between minus 3 to 4 only, right? So what would be the resultant of this one when I'm substituting here? Okay, this is your x value. I'm substituting the x value in a of x, right? So what would be the values? So here I'll be getting minus 3 whole square when I substitute in p of x, minus of minus 3 minus 12, right? So this is what this is, 9 plus 3 minus 12, that is 12 minus 12, the resultant is 0, right? So over here it is 0, means what is the coordinate? I can take it as x comma y. Okay, y is equated to your p of x. So the coordinate here is minus 3 comma 0. Okay, let's look at the next one over here. Similarly, like that, minus 1 to the whole square minus of minus 1 minus 12. I'll get here 1, I'll get plus 1, I'll get minus 12. So the answer of this one is 2 minus 12. That is, at last I can write this one as what will be the resultant of this one? That resultant of this one is minus n as your answer. So the coordinates over here are minus 1 comma minus n. Hope this is clear to you, right? So when I'm substituting here 0, I will be getting the coordinates as 0 comma 0 comma minus 12. When I'm substituting the coordinates for 1, the values of 1 would be getting it as, the values of 1 would be 1 comma minus 12 only. When I'm substituting the value of 3, I will be getting 3 comma minus 6. Okay. Hence, these are the values which needs to be substituted in the graph. Right? So let me take some origin over here. So if this is your x-axis, I'm just drawing this roughly. Alright, I'm taking this as your center O. If you're observing on the LHS, you need what, minus 3. So this is minus 1. This should be your minus 2. This should be your minus 3. And the RHS, if you're taking it, 3 is the limit. So I'm taking a 1. I'm taking this 2 and I'm taking this one as 3, right? Similarly, you will be having the y-axis also, right? So this is your y-axis. Just draw it neatly. Yeah. In the y-axis, you need to substitute the values. So what we need to take on the y-axis? Y-axis is, look at the equations in the y-axis. You are having minus 12, all negative terms a lot, right? So what I will, I'll just take this one 0 and take minus 2, minus 4, minus 6, minus 8, minus 10, and minus 12. Okay, so these are the values of y-axis. Means this scale would be x-axis 1 unit is equals to 1 centimeter, and on y-axis 1 unit, if you're looking at this, minus 1, minus 1, minus 1, minus 10 is somewhere over here, right? The other one is 0, comma minus 2. That is this one, right? The other one is 1, comma minus 12. 1, comma minus 12 is somewhere over here. The other one is 3, comma minus 6. 3, comma minus 6. So this is 3, comma minus 6. So when I'm drawing this using the free hand, when I'm drawing this using the free hand, and similarly if I take the value as 0 here, 4 here, if I substitute here 4, the value what we'll be getting is quite simple. That is the other coordinate what we're getting is 4, comma 0. That is the other value which just comes over here, that is 4, comma 0. Hope this is clear up here, right? So when I'm drawing the graph, drawing these dots quite simply with your free hand, this polynomial is intersecting at two different points. These are the number of zeros. These are seen behind the zeros. Now, where it is intersecting? It is intersecting at x is equals to minus 3, and it is also intersecting at x is equals to 4. So, these are the zeros of the polynomial p of x. Hope this is clear, right? So, let's look at the next. Okay, let us look at the second bit. If you're looking at the second bit, the equation is x square minus 6x plus 9. I'm equating this to 0 to remove the roots of this one. So I can rewrite this equation as x into x minus 3x minus 3x plus 9 is equals to 0. When I'm taking the similar terms outside, I have left with only this one, isn't it? Only this is being left out, is equals to 0. So the roots of this equation is x minus 3 is equals to 0, or x minus 3 is equals to 0. Now when I'm shifting these numbers to the RHS, what would be the value of x? The value of x is 3 only. 3 and 3 only. Means this is only, there is only one of the zeros of this equation. Okay, so let's just see this one over here. I'm substituting different values of x for different values of p of x. Okay, so this p of x I'm taking it as to be on y-axis. Okay, as I'm having the value of 3 there, right? As we are having the value of 3, then 3 needs to be taken. Okay, as we have the value of 3, we need to take the value of 3. Similarly, I'll be taking some value of 2. I'm taking the value of 1. I'm taking the value of 0. And I'm taking, that's enough, right? So when I'm substituting the value of this in this equation, in the equation, that is 0 minus 0 plus 9 is your answer. So this is your 9. So what would be the coordinates of x comma y? X comma y coordinates is 0 comma 9 is 1. So when I'm substituting x equals to 1 in p of x, I'll get 1 square minus 6 into 1 plus 9. I'm substituting this equation over here. See that, okay? 1 minus 6 plus 9 is what we get it. Adding up these two, minus 6 plus 9, what we get it, right? So what would be the resultant then? What would be the resultant if you're substituting the different? Now when I'm solving this, the resultant is 4. Okay, I need to add up these two, so the resultant is what? 4. So the coordinate is 1 comma 4. Similarly, I'm substituting the x value as 2. I'll get 4 minus 12 plus 9. Adding up these two gives me what? Gives me 13. Gives me nothing but 13. 13 minus 12 is answer is 1. So here the answer would be 1, and this would be 2 comma 1. So when I'm substituting 3 in the equation, I get 9 minus 18 plus 9. Adding up these two is 18 minus 18. So the resultant of 3 is 0. That is, I'll get 3 comma 0, right? So I'm drawing this on the graph here. So this is your x-axis. I'm taking this as to be 0. If you're looking at the values over here of the x-axis, 0, 1, 2, 3, we're having only positive terms, right? So let us look at only the positive terms. 1, 2, 3, and this is your 4. Okay. Now if you're looking at the y-axis, you have up to 9, right? So this will be your y-axis. So only the y-axis is required. No negative terms is required. So this is your y-axis, right? Here I'm taking the distances as 2, 2, 4, 6, 8, and here is 10 here, right? So here the x-axis, what we have taken 1 unit as what? 1 centimeter. Y-axis 1 unit is equals to 2 centimeters. Okay. So looking at the first one over here, 0, 0,9, 0, 0,9, 0 is your on your x-axis, and this is your 9. This is 0, 9. Okay. Similarly, if you look at the next one, 1, 4, 1, 4 is over here, right? 1, 4. Similarly, if you look at the next one, this is 2, 1. 2, 1 is somewhere here. This is 2, 1. The next one is 3, 0, 3, 0 is here. Now, when I am drawing a polygon curve with your free hand, it comes out something like this. Okay. So this is your the 0. I can say that this is 0 of the polygon, which is your p of x. Hope it's clear to everyone. Let's look at the next one. If you are looking at the next sum over here, you are having these equations over here. So let's see how do we do this. Can we able to split this? We are unable to split it. The justification of this answer is we cannot split it. We cannot split the equation. Okay, we need to remember that. So how do we remove the equations of such equations then? For this, I will be checking here the value of different x's. That is -1 I'll consider, 0 I'll consider, plus 1 I'll consider, and 2 I'll consider. That could be enough, right? And p of x, which is drawn on the y-axis. Okay. So for this, when I'm substituting here -1, the resultant is what? 1 plus 4 plus 5. If I'm adding up all this, the resultant is how much? 10. The resultant is how much? 10, right? So when I'm taking the x comma y coordinates, there that would be -1 comma 10 here. If you look at the next one, 0. When I'm substituting 0, right? The value of the exponent is 0 only, and only this will be left out. When I'm substituting +1 in this equation, I'll get 1 minus 4 plus 5. Then what would be the resultant? If I do this to add up, -4 plus 6, the resultant is only 2. So for 1, I'm getting what? 2. For 1, I'm getting 2. Similarly, if I solve for 2, I'll be getting what? Only 1, right? So let us draw the equations over here. The drawing first. This is your x-axis. If you look at the x-axis, we are having -1. -1 I'm writing here. We have 0, 0, 1, 1, 2, 3. Only 1 is enough, right? Yeah, only 1 is enough. Now if you look at the y-axis, you are having up to 10, right? To here, right? As there are no negative terms, I'm just leaving it out, right? So what I'll take here is I'll take the differences of 4, 8, 12, and so forth. So what would be the thing here? The x-axis. I can write 1 centimeter equal to 1 centimeter only, and the y-axis 1 centimeter is taken as 4 centimeters. Hope it's clear. So let us do the first one now. -1 comma 10 -1 comma 10 would be keeping it out somewhere over here. 0 comma 5 0 comma 5 would be somewhere over here. 1 comma 2 1 comma 2 is somewhere over here. 2 comma 1 2 comma 1 is again somewhere over here, right? So looking at this value is moving up and it rises. Okay, if you continue the value, it will be rising. It is not intersecting at the x-axis. Therefore, I can write the conclusion as the graph. As the graph is not intersecting. As the graph is not intersecting on x-axis, we observe that it has no zeros. Hope it's clear, right? It has no zeros at all. Let's look at the next one. Fourth one over here. So let's look at the equation. So let me try to remove the roots of the equation first. Here I can write here x into x. Similarly, plus 4x minus x minus 4 equals to 0. Removing the similar term outside, that is x plus 4 minus 1, and similarly x plus 4 is left out on the other side equals to 0. So x minus 1 is one of the root, and the other root is x plus 4 is equals to 0. Now I'm shifting this one to the RHS. Then I'll be left out with x is equal to 1 or x is equals to what? Minus 4 are the roots of this equation, right? So these are the zeros of the equation. So let's see using the graph method. So let's substitute for the different values of this one. So first of all, you need to take the value of x. If you look at that, value of x is minus 4. So minus 4 needs to be include minus 3, minus 2, minus 1, 0, and 1 is the last root, hence I am including that one also. Now e of x, then I am substituting the value of e of x, that is minus 4 to the whole square plus 3 into minus 4 minus 4. This comes out 60 minus 12 minus 4. The resultant of this one is what? 0. So here that e of x came out to be 0. Similarly, if you are doing for minus 3, the resultant is minus 4. Similarly, if you are doing for minus 2, the resultant is minus 6. Similarly, for minus 1 is also what? Minus 6. Similarly, for your 0, that would be your coefficient minus 4. For 1, it would be 0. Okay. So what would be the different coordinates then? X comma y. If you see this, the resultant is minus 4 comma 0. Minus 3 comma minus 4 and minus 2 comma minus 6 minus 1 comma minus 6 minus 0 comma minus 4 and 1 comma 0. You need to substitute the values of x in this equation to get the values of this. Okay, so and let me draw the x-axis properly. X-axis taking somewhere 0 over here, there are negative terms, more a lot negative terms, right? So this is what? Minus 1, this is minus 2, this is minus 3, this value is minus 4. So and similarly on the RHS we are having only one value, right? One is available and limit 2. So this is your y-axis, that is your p of x-axis. Okay, this is your p of x-axis. If you're looking at the y-axis, we get y0, minus 4, 6, 6, minus 6 is the last one, right? So let me take it as minus 2 here. Not minus 2, this is plus 2, right? So we should be taking the lower part. Minus 2, minus 4, minus 6, and minus 8 as is required. So I can write this as x-axis. I have taken 1 centimeter equal to only 1 centimeter. For y-axis, 1 centimeter or unit is equals to 2 centimeters. Hope this is clear. So let us substitute this. Minus 4 comma 0 is somewhere over here. This is minus 4 comma 0 point. Now minus 3 comma minus 4, which is somewhere over here. Minus 3 comma minus 4. Similarly, minus 2 comma minus 6. This is minus 2 comma minus 6. Similarly, minus 1 comma minus 6, it's over here. Similarly, 0 comma minus 4, it's over here. And 1 comma 0 is something but this one, right? So when I am drawing the graph joining all these coordinates, I'll be getting a polygon which is something like this. So if you are observing the graph directly, you are able to see that these would be the zeros. Therefore, from graph, it is said that, it can be said that zeros of the polynomial, what is zeros? The zeros of the polynomial p of x are 2 at 1 is x is equals to minus 4 and x is equals to what? 1. Hope this is clear to everyone, right? You need to remember this. So that would be this one. So let's look at the next one. Now you need to draw the graphs of this polynomial. Given equation is here, this equation. Okay. So if you're looking at this equation, the roots of this one would become as, see, I can write x square minus 1 as a square, and this one only means I can write this x plus 1 into x minus 1. So if I equate this one to 0, x plus 1 is equals to 0, setting this to the RHS, that is, you will have x is equal to what? Minus 1, or x minus 1 equals to 0, or the value of x will be what? 1, then I'm putting this on the other side, right? So the zeros are how many? The zeros are over here, 2 are there, right? So let me take the value of x and the value of p of x. As the value of x we are having here minus 1, 0 and a 1. These are the different roots of this equation. So we'll take one more value 2, and here we'll take minus 2, right? When I'm substituting this in the equations, I will be getting here 3, and this is 0 obviously, and eventually this is also 0. And when I'm substituting for the value of x is 1, this becomes as to be minus 1 over here, and over here the resultant of this one would be what? It would be 3. Hope this is clear. So what are the coordinates of x comma y? The first coordinate of x comma y is, first coordinate is minus 2 comma 3, the next is minus 1 comma 0, the next is 0 comma minus 1, the next is 1 comma 0, the other one is 2 comma 3. So let me draw this on the graph directly. This is your graph. I'm taking it as your origin. Origin has equal number of this one, minus 1, minus 2, and this is your minus 3, right? This over here I can write this as 1, 2, and this as your 3, right? So this is your y-axis. This is your y-axis. On y-axis also we are having less numbers. So let me write this number as 1. So this is 2. This is minus 1 is this one, and this is your minus 2. Hope this is clear, right? So I'm substituting the first value minus 2 comma 3. Minus 2 comma 3, where it is over here 3. So this is what? Minus 2 comma 3. Okay. The next one is what? Minus 1 comma 0. Minus 1 comma 0 is over here. The other one is 0 comma minus 1. 0 comma minus 1 is again over here only, no problem. The other one is 0 comma minus 1, fine. 1 comma 0, 1 comma 0 is again here, that is, the other one is 2 comma 3. 2 is over here, 3 is over here, right? So this is your 2 comma 3. So when I'm joining this using my free hand over here, the other one is yeah, this one, and the other one is this one over here, right? Hope this is clear to everyone. This point is 0 comma minus 1, remember it, okay? So if you're looking in the graph, it is x-axis, so the zeros are only 2. So from graph, I'm observing that zeros are 2. At where are they? They are at minus 1 and 1. Hope it's clear to everyone. Okay, now he's asking why this is equivalent to this one here. Okay, let's see all the zeros of the polynomial. First thing is first, this is, now I'm substituting here. So let us substitute. Let x is equal to what? 1 by 4. So when I'm substituting in p of 1 by 4, what I will be getting? I'll be getting 4 into 1 by 4 to the whole square plus 3 into 1 by 4 minus 1, right? So when I'm solving this one here, 1 into 1 by 4 into 4 can be written over here, plus 3 by 4 minus 1. 1, 4 and other 4 is cancelled out. So now I'm left out with 1 by 4 plus 3 by 4 minus 1. Now I'm taking this number to the other side, that is I'm equating this denominator part, 1 plus 3 minus 4 by 4. Adding up these two gives me what? 4 plus 4 by 4. So not plus, this is minus. So the resultant is 0 by 4, that is I can write it as 0. Okay. So now the next assumption is I am taking the other value, that is minus 1. Let x is equal to what? Minus 1. When I am substituting in, p of minus 1 is equal to 4 of minus 1 to the whole square plus 3 into minus 1 minus 1. So I am substituting this 4 minus 3 minus 1. So what is the resultant of this? The resultant of this is 0. Okay. Therefore, as P of 1 by 4 and as P of 1 by 4 and P of minus 1 is equals to 0, I can say that these are the values. These are the values of P of x is equivalent to 4x square plus 3 times of x minus 1 is equal to 0.